Okay, so
Okay.
we have lots of agenda items. Let's start with the one with GN. So do I have to explain the background?
Actually, Benedict has posted ordering.
Can we start in a different order because I don't have a lot of time?
Okay, sure. Let's go with whatever you want to talk about. I think async hooks first, right?
Well, async hooks might be an obvious one, yeah.
Uh-huh. Okay. Go.
So should I talk about this?
Yeah, sure.
Yes.
Okay, so is everyone on the same page with regard to the performance impact of async hooks? Is everyone aware that we faced a 30% performance drop just by enabling this on promise and async heavy code?
I think so. So I was around, I mean, I work at the same place Trevor does when he was making it, right? And a core design consideration was that for it to have no impact when it is not enabled, but be aware of there will be an impact when it is enabled.
Okay, so is this so there are different opinions. So some people see this as a hard blocker, whereas other people are like, yeah, maybe we can still make it non-experimental. I think this would require a serious redesign of the promise hooks, and I for example, Satya had this idea of speccing promise hooks instead, which would allow us to use it in a browser as well, and not have this one-off solution for Node only. But this would take a lot more time. So people, in the meantime, people don't really have a solution for performance monitoring, except relying on this experimental API, since there is no way to monkey patch await or async functions.
Speaking a bit more to the overhead side, I think the initial design goal was definitely that I think it should have no overhead when disabled. But I think what we're learning is that when it's enabled, I think people expect it to be somewhat comparable to the other mechanisms available before, which was monkey patching based context tracking. And I think it's significantly more overhead than that.
Right. If it's going to have, I mean, 30% seems like it, would you ever be able to turn that on when you needed it is the question.
It seems to work reasonably okay when what you're doing is local, just kind of local analysis. Any kind of server environment, production environment, if you wanted to try to actually get any kind of decent trace, then yeah, it's massive. And if you wanted to do any kind of ongoing analysis, information capture, yeah, I can.
There is one thing to be said that is I don't remember which version of Node, but it's already shipped. Domains are based on async hooks, and currently all the systems, the systems that I know of, well, some of the systems that I know of for doing this context tracking rely on domains, which means they rely on async hooks.
That's not entirely true. Lots of people are using continuation local storage, which does not use domains.
Yes.
So, but the thing is that doesn't work anymore because that mechanism doesn't work for async functions.
Yes. So more or less, we are coming out of the only available mechanism is async hooks at this point.
Right. So I guess the fundamental question, I think, if I'm understanding Benedict, is that so there's performance challenges in async hooks. So the most pressing concern, I think, from Benedict is that I think this should not move out of experimental just yet, because depending on how promise hooks might need to be changed, async hooks might need to be changed. Is that the correct interpretation, Benedict?
Yeah, I think by now. So Satya brought up this idea as well about either having a build step or porting promise hooks and to extension async hooks completely to JavaScript. And I think these are by now the only two viable solutions that I see, especially after talking to Adam and Dominic now about this idea that we have been discussing in the morning of just making as an intermediate step, just making async and await interceptable, which is not a good idea for many reasons. So then the only way forward is either to have everything written in JavaScript so that you don't pay at least for the boundaries, also the rest of the async hooks, not just promise hooks, or maybe we do a step before.
Sorry, to be clear, are you saying promise hooks have to be in JavaScript, or do promise hooks and async hooks have to be all JavaScript?
I think long term you probably want to. So once we fix this for promise hooks, we probably hit the same thing then for timers or whatever. So I think that also ideally you would have to have the whole async rep implementation in JavaScript, which should work because the timers are created from JavaScript. So you just need to make sure that you do this on the right side.
For timers, it's already done in JavaScript, at least for some of the timer parts. I don't think we can do it fully in JavaScript for certain parts of the HTTP implementation, the way the parser and stuff works. And possibly also for TLS.
And also there's native modules that also will need to use async hooks. And so we don't want to penalize the native module use case for async hooks either. So right now, the current implementation basically uses some tricks to expose a native array to JavaScript in a backhanded way to provide both a JavaScript and a C++ API, and that allows it to be somewhat fast.
So that sounds like we already used that trick, and we could extend it.
Extend it to promise hooks.
Yes.
Yeah. So the core data that you need to use in either side of the API, promise hooks or async hooks, that data needs to be available in a fast way, both to C++ and to JavaScript. So the way it's done right now is the data is actually stored inside a typed array that is off heap, and basically we have a pointer to it from C++. So we directly mutate the data and JavaScript just sees it. So I guess that could be something that could be explored for promise hooks. Sounds like more of a contract between V8 that needs to be figured out.
Well, with the promise hooks, if all it is passing, IDs and kind of event identifiers, then yeah, that works great. There's no reason we're not passing any object references, are we?
Right now, it passes a promise object.
Okay, so that would be the redesign then, because maybe the typed array works great for anything, for all the other stuff, but not so much for that.
So I'm not sure if it needs to pass the promise right away. We might be able to have a getter for it.
Yeah, yeah, deferring that where it's only retrieved when the user actually needs it would be good, I think.
So there's another thing. What about the destroy hook? Because this is one of the main problems, actually. This is why the init hook is so expensive. This is why we need the sweep reference and the finalizer. And you don't even have a guarantee that it's ever invoked. So, so if you talk to 10 people, then you have 11 use cases for the destroy hook. But what is your stance on this? So does it make sense? Is it really essential, or is it just it's because we can?
I think in most of the cases that I've seen for the destroy hook is make sure things are getting cleaned up, so we don't have so we can verify that we're not having like memory leaks or make sure that things are actually getting destroyed. I think that if we could find a way where it's only enabled on request, and then in every other case it's off by default, we don't have to do it. So there has to be an explicit opt-in for it. That might be an approach.
There was also the use case, I don't know if it's tied to async hooks, probably not, but for postmortem debugging, knowing when a promise is not going to need, knowing when the promise is truly not handled. That was the other case where.
Yeah. So all of these cannot be reliable, right? Because the destroy hook, like promise, may not get garbage collected for a very, very long time or forever. So
it's true. but it's the best we have today, right?
My guess is that it would have performance challenges that I think Benedict is worried about.
Well, it's not just performance. So it's partly, but the way it's currently done, it's less ideal. And if the destroy hook is really important, then we probably, instead of working around this on a node side, we should probably just collect promises in our GC already, and that's at least way cheaper than wrapping it into wrapper objects and what we do right now, essentially. Okay, so I guess if no one has any more interesting data points here. So by the way, the 30% was on Happy 17, which is very promise heavy, very async await heavy. So I also benchmarked Coa, and that is between 0 and 10% regression, so it's not bad, not that bad.
So for me, so the way the new Happy 17 is written and so on, it's heavily using async await. And I think it's like we are going to see more and more application doing exactly that in the future. So I think we need to find a solution to improve, because in async await, as the example from Ali on Twitter showed up, it allocates a lot of promises just for running an async function. So because of this, to me it seems very clear that a solution needs to be found and fast, or a long-term one that we are sure it works. Okay, so the question for Benedict: are you certain that the problem is about the boundary crossing?
Yeah, as I said, it's only part of the problem. So just supporting the destroy hook makes the init super expensive. So init has to create this wrapper object. This wrapper object creates a weak reference to the promise. You then slap a link to the wrapper object onto the promise, and then you go back to regular promise handling.
So in order for this to be fast, that needs to happen in JavaScript, and we need a spec for doing that.
Yeah. I think yes, a spec would definitely help us long term.
So in the case, and like if this stuff is happening in JavaScript, in the case where we are using the C++ APIs to create the promise and resolve the promise over in C++, and we're only passing a reference back to JavaScript, we'll still get the hooks called over in JavaScript. Okay, I think it should work. Should be fine. Yeah, you're right. It's a definite reworking of it.
So what I realized, I've been working on this promise performance now for since the beginning of the year, and I just landed one big CL, which essentially doesn't improve performance really. It just tries to make the number of reduce the GC frequency, and this gave a 20% boost on the Wikipedia benchmark already. Just not even optimizing anything, just allocating less. So that means the more you allocate and the more frequently you cause GCs, the worse your performance will get. Because you work against the generational hypothesis, and all of the short-living objects in the application all of a sudden make it into old space, or some of them, which makes the GC more expensive for your application.
Yeah.
Which means any additional object that we allocate for promises is going to hurt us.
Yep. Definitely seeing that in the FS promises benchmarking, so seeing that behavior. Okay.
I have a big question for the node folks. I've only heard about the async, the promise hooks performance problems. What about the other hazing hooks? Are they not a performance bottleneck at all? Alternatively, if we had fixed the promise hooks performance problem, would that make async hooks production ready?
Matteo, you could probably speak to this better than.
Sorry, I couldn't understand. I couldn't hear all of it. Can you repeat, please?
The question is, what is the performance impact of async hooks in general, aside from the promise hooks?
I don't have specific numbers, okay, but from what I've seen so far should be around 10%.
Yeah, that's basically what I remember too. I think just by invoking JavaScript functions for each call, you take about a 10% overhead. I do know, this is part of what I've been mentioning in the chat, that a lot of that overhead is just from calling nextticks everywhere. And we have a very similar problem already with nextticks as like async await would with promises, except there's a little bit less allocation. But you call the callback so often because we schedule nextticks literally everywhere. And like one of those is actually kind of useless too, because like the destroy and the after call are basically the same thing, but the way it's sort of like quote unquote spec'd. We need to call them both. So yeah.
And is that 10% acceptable for production? Because like, there's no way like we can get rid of that unless we pull most of those into V8.
I think 10%, as long as it's predictable, I think it's fine. Like the major problem with promises, and it's first is 30 is 3 times 10, but currently all the APM solutions that I have seen, the best performing ones offers like more or less a 10% overhead, at least the best ones. There is one specific one that performs way worse, but I don't want to mention it. But that's the current approach of monkey patching can do 10%, okay, which should be our target. So we should more or less. I think that's my point there.
Wait, 10% with monkey patching on the JS side, or 10% with the other async hooks enabled?
No, 10. But it's more so. Currently, most APM solutions that I've seen claims, and I've kind of measured to be at 10% overhead, around that figure, and async hooks without heavy async await usage leads to similar numbers.
Okay.
But we need a proper write-up on this. Like we need to write some solid numbers.
Yeah, we've got some data points too. So go.
Matteo, this 10% what you mentioned, is it the overall impact of an agent, or only the part which is dealing with the promises and async operations?
No.
Okay.
I'm talking about the non-promise code on like node 6, node 8, okay? Non-async await paths.
Okay, because what we have seen is that these agents has really low impact for non-async operations, but for async operations like promises, the overhead is huge. So it's comparable with this 30% what you mentioned earlier for async hooks.
Yeah, well, it's like on the promise side, it can be very bad. So when I'm talking about 10%, more or less 10%, it's if you are using any agent that does monkey patching, monkey patch HTTP, monkey patch Mongo, monkey patch all of it more or less, and in the intercept and reconstruct the things. So that's what I mean when I'm talking about this overhead. Okay, with promises, it's currently as bad as it is right now. So I'm not saying it's better. Okay.
Okay, thanks for the clarification.
So also,
anyway, we need a good write-up on this. Okay, a data point that we're missing.
All the existing solutions don't work with async await, right? If they are based on monkey patching.
I don't think so.
Okay, so unless someone wants to mention, so I like the idea of the write-up. Maybe Matteo, would you be willing to start this?
I'll set it. It might take some time because I'm some heavy traveling, but I hope I'll do. I hope I'll do my best to do some checks and writes. Get some number.
Okay, so should we move on to the next topic? We
Yes,
have
please.
So I want to give an update on JIP2GN, what I've been working on the past few weeks. So we are going to remove JIP files from V8 in 6.6. So that's in like about 1 or 2 weeks. And once that's done, Node.js will have to inherit the JIP files from V8, essentially taking them over and currently moving them into a central folder so that it's easy to hand over. And currently in our branch of Node.js, in our fork of Node.js, there's an additional configure option to build V8 with GN. So if you do configure -- build -v8 with -gn, and then it will fetch the dependencies, and afterwards, if you do make, it will once it requires the V8 dependency, build the V8 part with GN. So that already works with Mac and Windows, but it's not really designed for actual distributable builds. So this is sort of a crutch for us to be able to test against Node.js as we develop V8. But I was expecting that every single time that you update Node.js to a new V8 version, you would have to update the JIP files, because otherwise platforms like FreeBSD wouldn't be supported. Is there any questions on how we should do the handover?
I think Michael Zasso is probably the most relevant person here. He invests a significant amount of effort updating the V8 versions. So as far as the handover is concerned, I think there will be probably some hand-holding or some collaboration required at the time when we had removed them. So we can probably do those on issues. I think Michael is on the call, so he can add in. Or
yeah, I see him on the call, but he's muted. So
yeah, I'm here.
Hi.
Hi.
So I guess the first thing that you will see is on the Canary build that you're maintaining day to day. So I guess at some point, once I remove them, remove the JIP files, you will have to copy them over into the branch that you're maintaining.
Yes, well, this branch is maintained automatically, so I will have to change the script to deal with that. But about the update of the JIP files, what kind of work is that?
So usually that's not a lot of work if it's just about maintaining file lists. So there exists a script that compares JIP files with GN files to figure out whether any file is missing. And GN has a feature to do, I think it's called GN desk, as in description, that shows a basic overview over what a certain build target requires, like what dependencies it has, what kind of configs it has, what includes, and what source files. So I guess by using that, it could be fairly easy. That's the usual case. If we at some point add build steps or change build steps, that will then be a little bit more involved, because then you have to essentially translate GN rules into JIP rules.
And is that, do you expect that to happen often?
Maybe once a year. So one thing that's probably going to happen within, I don't know, 2 or 3 months is that we are going to move some of the built-ins off heap into the binary. And that will probably change the way we run mksnapshot. But I'm not entirely sure how much that will change and whether that even adds a build target. I don't think it will add a build target. It will change some output of the MQ snapshot run. Yeah.
Okay, so for the day-to-day update of the Canary branch, we could probably make something automatic, I guess.
Either that, or you could just use the GM build for day-to-day, because that doesn't require to keep zip files updated. If that's a solution for you.
Okay, so then we will lose the nightly builds for some platforms.
That's true. Yeah. So I only tested that for Linux and Mac. I was still planning to also fix that for Windows. But beyond that, I probably won't be able to do that for FreeBSD because GN just doesn't support it.
Yeah, and there's definitely extra work for Power in Linux 1. I know Montesir and John have been looking at that, but it's not at the point where it's as smooth in terms of the pulling the resources and stuff like that doesn't pull for those platforms, even though we've built them. So.
Okay, but that's essentially the status quo. I'm expecting to essentially pull the plug in 1 or 2 weeks. And by then, all the zip files should live in V8 zip files folder. Any more questions, or should we just move on? Okay, let's move on. GCC support in V8 is the next topic. So
the topics that Benedict put together, because I think he said he had to go. So I don't think we've covered his list. He had workers, memory tooling, and extras.
Yeah. Okay.
Yeah. Benedict? So maybe so there's this other item that was separate. What is the general perception of async and promise performance in Node 9, Node 10? Is there anything that you feel like, okay, if you have time, do this now? I ran into performance bug A and that's terrible, or I ran into some other issue.
The only thing I've seen is just the allocations issue that we've already talked about, and the frequent GCs. And it sounds like the work that you've already done on reducing those allocations is great. The one thing so with the FS promises, we're creating the promise in C++, and some of those functions are wrapped in async functions, right? So we have an async function in JavaScript, call down to across the boundary to C++ and create another promise for the return. And the reason we do that is to catch the errors, the input argument validation errors, and keep those from being thrown synchronously. We want those to be promise rejection. So in those cases, it's actually 2 promises that are being created there, right? So if I would appreciate if you do get a chance, take a look at that and see if there's ways of optimizing that down.
So if you create this, you create it in C++ by using the promise resolver?
Yeah.
Okay, that means you create it in JavaScript, because I just figured out in the morning that this calls into JavaScript land. So we should optimize that. Okay.
Right.
Okay.
So
good to know.
Yeah, that's the only real thing that I've had in that, and anytime I try to actually monitor these things, but we've already talked about all that.
Okay. Cool. Okay, the next item then is what's the status of workers, and specifically, what's your stance on? So I know there's a Spectre item, but maybe we can talk about this before. What is your stance on shared array buffers and workers?
Is Anna on the call? Did she make it?
No, Anna isn't.
Anna wasn't at the TSC meeting, so I don't think so.
No, Anna's not here.
Bummer. Anna would be the best person to talk about the state of the workers stuff.
It probably makes sense to just sync with her directly, yeah. Because
okay, I can talk to Dana then if no one else has any opinions or insights.
Is Chrome gonna keep shared array buffer turned off, or
for some time? Yes.
But
So
Node doesn't necessarily have to do the same thing, right?
So I don't think we have any definitive decisions on what to do with shadow array buffers, but I think the current goal is to have them re-enable them at some point.
Maybe Adam wants to speak to that.
I mean, I think I can say that's about what Yang said is about right. Like we want to keep them turned off for now, but we're trying to figure out when we can enable them. And that's our hope for the future, is to have them back on as part of the language.
Okay, so no one wants to speak to the workers.
Yeah, Anna is the one that she's the one that has the most context there, has done the most amount of work on it. And with regards to core, is pretty much just waiting on her to be ready to kind of push those bits into core. So
I can sync with her. That's easy. She's in the same time zone. So okay.
Yeah, let's just do that.
Then as the next topic, V8 extras in Node. This came up recently. Maybe Yang, you want to?
Yeah. So V8 extras. V8 extras used to be, what we sort of ad hoc implemented for back when I think streams and a couple of other features were supposed to be implemented in JavaScript in Chrome. And out of performance considerations, essentially, we exported a bunch of built-ins, either implemented in JavaScript or directly in Crankshaft back then, inlined, to Chrome so that they can use it. And yeah, and it stayed since then. It didn't really change. And we didn't really develop it further. There's not a lot of test coverage. And my stance is that we should not use it if possible, because it's sort of a bunch of non-standard features that's not really part of the JavaScript language in the sense of being part of the spec. And yeah, I don't know.
So what? Wait, why is it on here then? Like, what's the compelling case that someone might want to use it for?
So apparently, there is a pull request for Node to expose them for Node.js.
Oh.
And I was pushing back a little bit there.
I think the goal is to use private symbols.
Yeah.
That's why they want to make it public. Well, public to Node internals.
But even if we were to expose that, you would need to be careful, from my understanding, that you don't leak anything about the private symbol to untrusted code, right?
Right. So you definitely have to make sure that you don't store it anywhere that's accessible from outside. If you use it as a as a key in an object, that should be fine. But honestly, I think we should work on a different solution than just exposing them through extras, because Benedict is already working on removing features from V8 extras as much as possible. And having one more user for V8 extras is not going to help this.
Yeah, it seems reasonable to me. I mean, also if like the test coverage is bad, that doesn't really sound very good for us to be using. So
yeah, it's essentially some sort of hidden API that should not be there.
Yeah, that makes sense.
For private symbols, weak map is the straightforward thing to use that already exists. And in the future there'll be private statement classes. So I would hope that existing things and new things will help fill those gaps.
Yeah, I don't think you have to convince us too hard not to do things that make your lives harder. So
okay,
we'll we can stay away from that.
Just a question: were there any like debugging tools in V8 extras?
No, I don't think so. No.
Okay.
Actually, its feature set is not very big. It's I think call function is one, and then a simple version of a bind, and I think private symbols. That's about it.
Yeah, and there are multiple
internal
entry
arrays.
points to promise built-ins that bypass a couple of checks.
Yeah.
So it's also kind of dangerous to use.
Right, and internal arrays, and using that would be really dangerous because that could potentially screw with V8 internals.
Sounds fun.
Yeah.
Is there any plan to also remove the native syntax as well over time?
Yes, I would say so. So the native syntax only exists because we have internal JavaScript, right? We have a bunch of built-ins that's implemented in JavaScript, but we are migrating away from that. We would like to go into a future where we don't have anything implemented in JavaScript in V8 anymore, but instead in CSA, code subassembler, and or in C++, depending on what the use case is and what the performance requirements are. And once we don't have any JavaScript anymore, there's no point in having native syntax.
I'm just asking because there are some things that I used to use about the optimizer when talking about debugging tools.
We probably will have them still enabled for testing, because we do have a lot of tests that put functions into an optimized mode, or de-optimize them, or check whether they're optimized, or check whether there are certain arrays and certain layout, stuff like that. But other than that, I don't see any future for native syntax.
Okay.
And yeah, for debugging purposes and for just hacking. Okay.
So I guess we're on the same page with respect to DV8 extras. So next topic would be memory tooling. Young, you want to start?
Yeah, so about memory tooling. We've been thinking a lot about how people could, how people debug memory leaks and how we could make this better. And one thing that became apparent is that apparently heap snapshot is not really a good tool, or at least not as good as it could be. I mean, it's powerful if you know how to look at it, but often it's not obvious how to look at it. So one thing we've been thinking about is how we could add information to it. And we've been talking to Bradley about this. And it seems that we could annotate retaining path with the source position of when this retaining path was created. That would help a lot.
Yes, there are a few other things that we also talked about. Adding integers for character offset of where functions exist for the shared function info was another one. I'm a little bit worried about your retaining path idea because I feel like it may get to be a very large addition to a heap snapshot.
Yes, and it wouldn't work on production.
Yes, but if it can be turned off, that seems okay for development.
Yeah, so currently we don't really have any concrete idea. One other thing that I want to throw in here is that maybe we could work on some way to turn memory dumps into heap snapshot.
That was definitely discussed in the postmortem working group in the past, so I think there'd be interest in that.
So working on a prototype that like leverages like the LL node libraries. That it's kind of, we have like a prototype that's kind of working right now that can turn a core DOM into a heap snapshot. So that's something we started looking into as well, because the Chrome Dev tools offer a lot more usability and features for a vast majority of our engineers working on this stuff.
The other thing I'll add is actually there's another memory leak debugging profiler in V8, the sampling heap profiler. And it turns out actually people are still not aware of it. So, it'd be really good to get feedback on how well that works or doesn't work, or whether it provides useful info, or it could be changed in some way to provide more useful info.
So I actually mentioned that when I talked to Bradley, and one feedback I got is that allocation sites sometimes, more often than not, don't help, because if you have factory methods that do the allocation, then, well, you know, it's all the same location, but you don't actually know where it gets retained.
Right. Yeah, it's a different view on the data. And the other thing that's not helpful right now is that the allocation sites are not accurate. Like inline functions are not reported to the stack, so that causes a problem as well. But yeah, I think if more people were to try it out and see if this is useful at all, that would be good.
Has there been any serious thought to changing off the goofy JSON format?
I actually talked to I talked to Yuna about this as well, right? I think this is something we want to work on as well. But Ulan is the person who is working on Keep Snapshot most these days. He has to figure out. He wants to figure out. Like fix the heap snapshot with regard to retaining paths first, because currently there are some tricky bits that just don't work correctly, and we don't trace through wrappers. So that's one thing that should be fixed before that. But yes, we have that on our radar to come up with a new format other than JSON, because JSON is just not efficient enough.
And then I had two other questions, which I was waiting to ask you for this call. Did we ever figure out if there's a problem changing the maximum string size for things?
No, that should not be a problem. It should be just a easy change, I think.
And then in the same topic, do we have any examples of people actually using the source code in the heap snapshot, except for when there is a new function, eval, or something like a blob URL? I
don't have any data on this.
Okay.
We use it. We use that a bit to just to see functions. It's been helpful in the past.
Yeah, but it's limited to 1,024 characters right now for what's stored inside the heap snapshot. And I noticed some URLs were getting trimmed to that as well.
Yeah, the string length thing would be great to fix, because that, if you're losing data and resolution, then that's not good.
Yeah, and that's easy to fix, I think. I mean, it's just an artificial limit. Okay, should we switch to a next topic?
Okay, I have to leave.
One thing, bye Benedict. One thing I wanted to add about memory. If you can just wait for a second, Benedict. There's this point with you. It's a lot of the problems that I have seen are related to memory management and garbage collection are in fact not non-memory leaks. And it's more about what is happening with async await that Benedict exactly described, where there's a lot of things being put on, a lot of short living objects being moved from a new space to old space. And that's something that I keep seeing more and more. Well, I've seen a lot on Promise Code. And having any help in solving those type of issues, because at this point, the tooling for attacking those problems is very poor, because those things are collectible, okay?
Okay, so you're saying that a lot of memory issues are actually performance related because, usage patterns cause GC to overwork itself.
Yes.
Like, are you talking about like GC pauses, or can you be more specific?
Yeah, no, what is happening is a lot of I'm seeing, especially with async await code, I am seeing a lot of objects being moved, more objects being moved from new space to old space, and increasing the overall incremental marking and incremental marking GC consumption in general. Okay.
Are they like ephemeral objects that shouldn't move to old space? Is that what you're saying? Or
exactly, ephemeral objects that are being moved to old space. That.
Just to understand this problem a bit better, does it change if you set the new space size to a large value?
Yeah, that's one of the possible solutions. One of the main. However, I consider that a little bit of a hack to some extent. So if there is a value in there, probably it's a good one. Okay, that helps a little bit, but it's not. It doesn't. The major problem is the lack of tooling to know where this is happening in my application and what is causing this problem to happen.
You know what we should do? If you have any, repro case, it would be great to send it to us, because then I could talk to the GC people, and maybe they already have tools to figure this kind of things out.
Actually, we have Michael in the call, so maybe he wants to.
No, I think he already left. He had to go.
Oh, he's here. He's
Okay,
smiling.
yeah, here. I'll bring it up. I'll open. I'll keep a thread open on this, because this is something I've seen in the wild several times.
Okay. Can we just switch over to the next topic, as long as Michael is still here?
Benedict, you're done?
Yeah, sure. I'm done.
Okay, so we're talking about so GCC support in V8. The background is that
I'm off.
We have some plans with Clang that probably will require us to drop GCC in some future, like, I don't know, in a year or two, possibly. And Michael has prepared a presentation on what benefits we're thinking of if we do that. So
let me check if this sharing works here. If it does not, I can actually just tell you what's going on, but it should be. Not sure this is the right window.
Yeah, it shows.
Does it work?
Lots of stuff. Yeah.
No. Okay. I hope you see this now.
We see your.
We see your email.
We see your email.
That's the wrong one. Shit. I cannot find the window I want to find in this share screen thingy here. Or maybe actually that's this one.
Oh yeah.
Right. Okay. So V8 C++ toolchain support. Very simple. Historically, we are closely related to Chrome. So, which meant that we support GCC, MSVC, and more recently Clang. Chrome has been moving away from GCC and MSVC to actually the whole Clang-based toolchain for quite some time now, which means that also V8 just moved away. Like our test matrix for MSVC and GCC is getting really, really small these days. But it's not only testing and getting regular coverage, it's also that we and like Chrome and also we started using plugins. And this is actually what I want to talk about just for a few minutes here, which I think you can classify in two types of plugins. It's either optional or required ones. And yeah, we'll see what this means or could mean. Before actually explaining why we want to go there and what we already do and what the implications are, actually a short interlude. So V8 has the concept of handles, which we put on the stack to remember certain stack slots. This is useful for garbage collection in two ways. We can use it to do precise stack scanning because we actually know what a slot looks like and what kind of objects are in there. And we can also relocate, means move objects. So we can have garbage collection that actually moves the underlying object and still access those objects. This is all you need to know about V8's handles. So handles are expensive and they are problematic in certain ways, and they have been troubling V8 for quite some time. So we actually have already been writing a Clang plugin, which checks our handle usage, this thing is called GCMole, and we've had it in the code base for years now, which checks a few use cases. For example, here, in this use case A and B, both use cases actually are not valid because C++ doesn't define an evaluation order. So you might already have the variable bas in a register in both cases, which might break if the GC moves the object. So we have already been using Clang plugins. It's just we have been using them only to catch certain errors or bad patterns in our code. Now, what we are thinking about is actually moving to a system where we can replace the handles in bold on the left side with something that, like with a new system where we don't require any of those things by leveraging Clang's and LLVM support for generating stack maps, which the GC could use to get exact type information and essentially also move objects. So it's a very similar mechanism in essence, but the compiler would generate it for us. And the benefits would just simply be that there's like no more handles at all, which would be a couple. So we estimate that this is single digit to maybe 10% performance improvement, especially entering C++ from JS becomes way cheaper and any interaction you do in C++. It should also yield in more robust runtime code. But obviously the drawback is that we would have to build with a Clang-based toolchain at some point. And yeah, so this is an ongoing experiment. We are essentially trying out now how far we can get with Clang and LLVM support. And this is like, you can see it as a heads up that we might move into a world that where we cannot use MSVC or GCC anymore.
What effect would that have on native add-on modules? Like, would they be forced to use Clang as well, or?
I don't suppose that we will change the API because we would only generate stack maps for V8 for the V8 binary, and embedders would still have to use handles, I think.
Right now we are experimenting in that direction, yeah. One could imagine that you can also do this experiment even further and even go across API. We've been thinking about doing something like that for Chrome, but I think in general we would still have an API.
Okay, so basically, so it wouldn't affect add-ons. They could still compile with GCC if they wanted to. And
right, but that means but that means that if you want to build V8, you would have to use Clang.
Right, like so Node would have to compile with Clang, effectively.
Yeah. Does that introduce any ABI compatibility concerns with existing add-ons and API add-ons?
So I don't think the API itself will change because anything out like across the API boundary will still use handles. And
I think he meant ABI.
Yeah, ABI. Sorry, I said API. I'm sorry, ABI.
I'm not entirely sure.
I don't think ABI changes. Clang would not exist if it was not ABI compatible with Clang. ABI is defined by the
point.
Yeah. So I've been doing that before, like compiling V8 with Clang and linking that to GCC compiled node.js. That works. That's essentially what happens if you build V8 with GN.
Okay. The only other concern I would have is to make sure that we have Clang support across all of the core supported platforms, correct?
So for Windows and Mac and Linux, there is Clang because that's what Chrome uses, and I would assume for Android as well. Not 100% sure about other platforms.
I think some of the IBM platforms, such as AIX and might be problematic.
Yeah, I was going to ask Montazir to take a look at that. I don't know about ones like FreeBSD, ARM. I guess those are at least ARM is Linux.
ARM should be fine because Chrome is already using it.
Right. Okay.
I think we also have FreeBSD bots. We're not officially supported, but we at least compile for FreeBSD with Clang these days, as far as I know.
Yeah, and so the topic about Visual Studio support in V8 is essentially the same. We would actually want to move over from MSVC to Clang, if possible. I think there were some other considerations in addition to that, but I don't actually remember. But generally, it's the same direction. MSVC is going to be out of favor for Chrome, and so we are getting a lot less test coverage for MSVC and moving over to WinClang. But I'm not really sure whether that's possible for Node.js.
So one more thing, a bit more context. So Chrome was not moving over to Clang for quite some time now, or actually delayed the moving to Windows Clang, because MSVC was generating better code, but I think this is resolved now. So actually performance-wise, it should also be better to use Clang on Clang.
So Node will build faster on Windows? I like that.
Not sure about build time, but the code quality is better.
Oh, come on. You got to help us build it faster.
So actually, one thing that I noticed when I switched over our own infrastructure from building a V8 with JIP to building GN, that since it then built with Clang, I think one of the benchmarks actually got better by 6%. I think it was Uglify.js or something. So there's definitely differences in code quality. But yeah, nothing is actionable right now because we don't know yet for sure whether we will do this. But it will be nice to look out for it.
It would be good to give a heads up to the build working group because I think they will be most impacted by this as well. And having a link to the presentation that we can post in the build working group would be good.
Okay.
Sorry, just another question. There seems to be two things here. One is switching over to Clang. The other is the idea of using plugins for as a mandatory portion of the code base. Are these going to be done in stages where you start to remove handles and handle scopes inside the source? So can we anticipate that happening as a phase one, switching to Clang, and then a little bit of time before you guys start changing the source as well?
So we don't have any roadmap at this point yet. We are, like Michael already said, we are experimenting with this feature. But if it's successful, then we will have to think about how we roll this out and how we make it work with Node.
The first idea was to generate plugins that essentially create stack maps that verify that our handle system is correct. So that I think would fall into this idea of rolling out in stages. But yeah, we haven't gone that far yet, so cannot really say if that's feasible or not.
Next thing, snapshot support in Node.js. I'm sure some of you already saw the thread that I opened like 2 months ago about how Node.js startup could be dramatically sped up by supporting snapshotting in Node.js. I think the number was factor 4. And someone from Alibaba actually started working on this, and he has been making good progress. But one thing that will be necessary is to change the way node.js bootstraps, because currently the bootstrap module is really not really cleaned up in a way where you have phases where it's deterministic and other phases where things are dependent on command line flags, and yet other phases where C++ objects are allocated. So that will need some cleanup before this can move forward, I think.
Well, one of the pieces of cleanup that I'm looking at right now is talking about the command line flags, actually introducing a real kind of almost like a node options encapsulation for that, an actual options parser, something that will tie it to the environment, allow some of the cleanup there to occur and get some of the spaghetti code out of node.cc. And then start to take some of that initialization logic that's currently just kind of, jammed in the middle of node.cc and isolating that out. I think that's an important step one. Step two is definitely the bootstrap node file needs reworking. So if there are specific kind of lifestyle or life cycle milestones in there that you or phases that you would prefer to see, let us know, and we can start working towards that direction and whatever would make it easier to do that.
So one thing that would be really important is to cram a lot, as much as possible into a phase where it's definitely deterministic, so that you can either run that phase or just get it directly from snapshot. And then you can start doing anything that's dependent on build flags, on command line flags or their environment variables. But if you have a lot of things that's deterministic in one place, that would be awesome, because then we can do that. We can run that before we create a snapshot, and then afterwards you run the rest.
I think that seems reasonable to me. There are a couple specific things that kind of need to be loaded first, but aside from that, I don't think it should matter too much.
Yeah,
we can kind of work around, changing that a bit.
Yeah, and one thing that's a little bit problematic right now is allocating C++ objects, because as you load other internal modules as you bootstrap, some of them actually allocate C++ objects.
Yeah.
And I think in certain cases it can be problematic for the for V8 serializer to find them and put them into the snapshot. So we actually have a way to serialize C++ objects if they're referenced from JavaScript objects that we find in the tree, in the object graph. But if they are just hanging around somewhere else, then there's no chance of finding them.
Yeah, the process object and its various properties are some of the key problems there. One of the things that I'm looking at doing is separating the. Right now, all of the logic for the process object is contained it's just buried in node.cc.
Mm-hmm.
I'm planning on isolating that out into a separate separate file, so it's all together, separated from that, and then allow us to refactor down from there. So hopefully that'll be a good first step, and we can start cleaning this up so that we can actually snapshot.
Yeah.
So there are a few other concerns where we actually get a hold of things, pretty much anything from process.bindings.
Yeah.
We need to make a list of all the possible values ahead of time, at least when I last looked at the snapshot API. So the common JS loader and things like that, in order for it to be included in the snapshot without us starting from scratch, needs to have that list together so it can be serialized.
Yeah, I was going to say for some of the more difficult cases we might not be able to get around. It'd be nice if there would be some way for us to like mark or tell V8 that those exist like ahead of time or whatever.
Yes, there is a way, and we can discuss that offline if you're interested.
So I just want to kick off that there's something that should be done here, and it's probably not just as easy as something that one person can do. I think it's worth doing because we're looking at reducing startup from 100 milliseconds to something like 30 millisecond. And apparently Alibaba is interested in this because they want to use Node.js in their mobile operating system as application runtime. And if you start an app in, it is a noticeable difference if you are able to start up in 30 milliseconds instead of 100. Especially on mobile, it's probably more.
There's also a use case for these snapshots. They don't have to be limited to Node Core. I know Webpack is interested, once Alibaba is done, actually serializing after they bootstrap themselves.
Yeah, that will be somewhat more complicated, I think, because if we have during initialization a phase of deterministic stuff and then another phase of non-deterministic stuff, if you create a custom snapshot, this part becomes fixed as well into the snapshot. But maybe that's fine.
For them, that's okay. When I was talking.
Yeah, I know
Yeah,
that Allocating is really interested in this as well.
Yeah, there's a whole series of use cases, I think, for where that's going to be a good thing. So.
Mm-hmm. Yeah, once we have that, we can extend that to other modules like user-written modules as well. Yeah. Okay. Next topic, Spectre and Meltdown. So good news is that Node.js is not really affected. Not in the sense that Node.js has to do any patching. Essentially, you just have to tell people that the operating system has to be patched. But so one thing that's sort of the fallout of this is that V8 will have to introduce mitigations against ways to exploit Spectre in V8 by changing the way we generate code. And that will probably have performance impact. So we are going to, or we already have introduced a flag where these mitigations can be turned off. And with a use case in mind that maybe Node.js wants to disable them.
Is Chrome going to run? I assume Chrome is going to run with them enabled by default.
Yes, because that's the point, right?
Right. I'm just thinking that, like, in terms of coverage, test coverage, if we turn them off.
We definitely want to still run have test coverage with the mitigations off. But there will be differences in performance, and yeah, and you will not get coverage from having the same V8 version in Chrome as well, because it's just going to produce different code.
Right.
So the question is whether Node.js should use those mitigations or not, because there's probably some significant performance impact there.
Yeah, when you say significant, what kind of number are you talking, do you think?
I don't know. So we're looking at different strategies, but I would say 10% is safe to say.
Right.
So yeah. And so
they compile time? They're compile time only options?
No, they are. We're envisioning them as command line flags.
Right. Okay. So we kind of have the choice of like which the default should be on or off, and then we can expose it to people to choose too.
Yes. Yeah. So yeah. And then one last issue. This is something I wanted to talk to other V8 members first. And I haven't gotten around to do this yet. Trace events. I think someone was interested in having trace events being exposed to JavaScript, so that they can be used in JavaScript without too much overhead.
Yeah, this has come up a number of times. I don't see it as being super critical. I think kind of the more important piece of work, I think, is more at the C++ level, getting the macros fully implemented, getting but also one thing that is going to come up on the diagnostics summit here in a couple weeks is this idea, like right now within core, we have several instrumentation APIs. You know, the trace event macros is one, but there's also the dtrace macros, and there's other macros and stuff, and they tend to be very specific to those individual hooks. About having a more neutral API that allows us to plug in the targets on the back end separately, so we can instrument once. Once we have that, it would actually be like pretty drop dead simple for us to provide a JavaScript API if we if we wanted to go down that route. I have had some people ask for, hey, if you're emitting trace events, why not just expose a JavaScript API? It's a much lower priority than getting the instrumentation.
So the one way we could do this maybe is like expose a JavaScript function that does the trace event recording and then expose that, and Node.js can expose that function into JavaScript land and call it. And then in TurboFan, we can think about inlining this function into optimized code. And then this way avoid the overhead of entering C++. But this is just an idea, and I haven't checked with the people who know better about this yet.
Okay. I'm like I said, I'm planning on bringing it up at the diagnostic summit here in a couple weeks. So I think probably be best, continue the conversation there. We can kind of brainstorm. On what the possible directions are.
Yeah, because I assume the solution would be affected if there was going to be a neutral API. Might have to be. There might be a different fix for the problem than there would be if there isn't.
Exactly. Yeah. I mean, I would rather have the JavaScript implementation that we're exposing built on top of our neutral API. So if somebody wants to use dtrace or whatever else, they can still plug that in and get those.
Right. But then my thought would be, if that's well enough documented, maybe it still makes sense for like your suggestion of trying to inline specific functions that we've defined up higher might make sense.
Okay.
I just really appreciate the fact that y'all are looking into it. So.
Yeah, we're definitely looking into this. I think one last topic was REPL mode for V8 parser.
Yeah.
So this has come up quite a few times, right? So running things in the console, or in DevTools console, or in Node.js REPL is not really specified in a way in the spec. And people have different expectations on how this should work and how things should behave. And one thing, for example, is top-level await, which is not available in JavaScript, but is available in Node.js and in DevTools through a hack. The question is whether it makes sense for V8 parser to introduce a mode for this, or even go a bit further and try to get this into the spec.
So I actually like this quite a lot. I think I'm not so worried about await. I think the more interesting part for me is the potential ability to like redefine existing variables, because we have people that run into that on a not infrequent basis, like using let and const in the REPL, especially with like code they load out of the REPL history. So that would be interesting. I don't really have an opinion on whether or not we should try to spec it. Like maybe if it would be useful for browsers or other runtimes. The only worry I have one worry about it, and that's it. So the only problem then is you do end up with the REPL executing. I mean, you already do with top level await, but now you get it with variable bindings too, potentially, is that the REPL executes slightly differently than your code actually would, right? So
yes, exactly. So
but maybe that's not a bad thing.
This is something that you have both in the browser and Node.js. And I've been talking to Adam about this, and he would really prefer this to be part of the spec, because otherwise we're just adding unspec behavior to V8's parser, and
yeah.
You know,
I mean, I think
yeah. Good.
I think that like seems like a reasonable idea to me too. So,
so this
adding it, checking it out definitely seems like the right approach.
Okay, so I guess we should bring this up at the next TSC forum. Okay, we ran out of topics. Should we call it a day?
Hopefully.
Sounds good. I think we're past our 2:30 time anyway, so we're 2:50.
Yes.
Okay.
Right,
Okay, thanks for attending. I probably will do a summary of all of this, and I hope the recording will be still available.
It should be, yeah.
Okay, so that I can just, because I haven't noted down everything because we're just going fast.
Yeah, the either Mateo or I will be able to access the recording and provide it.
It should be
through,
publicly accessible,
here, so.
I think. But yeah, any of us can provide you with the link.
Okay, cool. All right then.
All right.
Thank you.
Thanks, everyone.
Okay, thanks. Talk to you guys later.